Orbiting the magnificent gas giant planet Jupiter is the mysterious icy moon, Europa, a seemingly frozen world about the same size as our moon. With a surface temperature of about minus 160 degrees Celsius, minus 256 degrees Fahrenheit, and a location that means it has to withstand a relentless pummeling of radiation, it would be easy at first sight to think of Europa as a barren ball of ice. But despite the harsh conditions it exists within, this fractured moon is one of the most promising places to search for alien life. So how could life survive on such an extreme moon? And if it does exist, what might it look like? If you enjoy my videos, remember to subscribe and tap the notification bell to never miss an upload. Many spacecraft have passed by Europa during their missions, but it was NASA's Galileo spacecraft that elevated our understanding of this icy moon to a new level. It discovered the first solid evidence that an enormous ocean exists beneath its surface, an ocean with possibly 2 or 3 times as much water as all of Earth's combined. Arriving at the Jovian system in December 1995 with the aim of exploring Jupiter and its large moons, Galileo passed by Europa multiple times, coming as close as 201 kilometers, 125 miles. It captured Europa's frozen terrain in incredible detail, allowing us to see close-ups of its cracks, ridges, and jumbled-up landscape, but also to find intriguing evidence of what might be happening below its crust. Galileo confirmed that Europa was geologically active. Its close-up images revealed that enormous cracks in the moon's surface had separated, and dark, icy material had flowed into the open gaps. Like spacecraft before it, Galileo found only a handful of impact craters, which are expected to build up over time as the surface is constantly bombarded by meteorites over billions of years. However, Europa is smooth, suggesting its surface is relatively young and that something had erased any large craters, such as icy volcanic flows. One of the most important measurements made by the Galileo mission showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within the icy moon by a deep layer of some electrically conductive fluid. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. There are even images from the Hubble Space Telescope that appear to show huge plumes of water vapor erupting from Europa's south pole, though they aren't high-resolution enough to be definitive. If Europa's surface is frozen solid, how could a massive ocean of salty water form? And if there is liquid water down there, could life have started in such a bizarre environment? While the icy shell of Europa is frozen as hard as a rock, the interior is warmer because it is heated by tidal flexing. The side of Europa closest to Jupiter experiences a stronger pull than the other side, stretching the entire moon back and forth, probably causing the long cracks across its icy surface as well as heating the interior through friction, similar to how bending a paperclip repeatedly generates heat. This constant flexing melts the internal ice and creates Europa's enormous ocean. But is it really possible for life to start on a frigid moon hundreds of millions of kilometers from the sun? Life as we know it seems to have 4 main requirements: liquid water, certain chemical elements, an energy source, and time. We have already discovered that Europa may have an enormous ocean of liquid water protected below its crust, and certain studies suggest this ocean may have formed just a few 100,000 years after the moon formed around 4.5 billion years ago, giving life, if it exists there, plenty of time to get going. What about the other 2 requirements, chemical elements and an energy source? Chemical elements are the building blocks of life as we know it, including carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements, which make up 98% of living matter on Earth, combine to form organic molecules essential to life. Scientists believe these elements were likely present during Europa's formation and may have even been added later when asteroids and comets collided with the icy moon. One example of chemical elements discovered on Europa came recently when the James Webb Space Telescope detected large amounts of carbon dioxide on its surface. Europa is shown as blue while the carbon appears white, likely originating from the ocean below. Next, we need an energy source. All life as we know it requires energy to survive. On Earth, life relies mainly on the sun for energy, such as through photosynthesis, where plants convert sunlight into energy that is then transferred to those who eat the plants. However, any life that may exist in Europa's ocean hidden below thick ice, would receive no sunlight, so photosynthesis couldn't work. Instead, life would have to be powered purely by chemical reactions, which could come from Jupiter's powerful radiation bombarding Europa's surface, or more likely from warm rock on the seafloor. As Europa orbits Jupiter, its interior flexes. The flexing forces energy into the moon's interior, which seeps out as heat. If Europa's rocky ocean floor is heated by tidal flexing, that process could supply energy in the form of chemical nutrients in hydrothermal vents, which are bubbling cauldrons of energy spewing out superhot water heated by molten magma. Such vents erupt with plumes of what looks like smoke, filled with chemicals that certain life forms thrive on, a process called chemosynthesis. This is what powers entire ecosystems around hydrothermal vents in the deep, dark regions of our oceans, where the sun's light cannot reach. The vents are the only places on Earth where life's ultimate energy source is the Earth itself. Huge red-tipped tube worms, ghostly fish, strange shrimp with eyes on their backs, and other unique species thrive in these extreme ecosystems. So, life on Europa seems possible, at least as far as conditions might allow. To imagine what life might look like, one place to look is within one of the deepest, darkest points on Earth, the Mariana Trench. The deepest point in the Mariana Trench, the Challenger Deep, is 11 kilometers, 7 miles, below sea level. Deeper than Mount Everest is tall. Yet Europa's ocean could be 60 to 160 kilometers, 40 to 100 miles, deep. Despite the depth difference, these environments may share similarities. Imagine a vast, pitch-black void filled with crushingly cold seawater. This oppressive environment is what life within the Mariana Trench has adapted to. But dive deep enough, and you'll find some of the weirdest creatures on Earth. The snailfish, for instance, is the deepest living vertebrate, found at over 8,000 meters, 26,246 feet, below sea level. This strange fish contains chemicals that keep its membranes flexible despite the crushing pressure. Other creatures, like xenophyophores, amphipods, and holothurians, thrive in even deeper areas of the Mariana Trench, adapting to life where it would be fatal for humans. So, if life has managed to thrive in Earth's deepest oceans, could it do the same in the even deeper oceans of Europa? Until we send a probe capable of drilling through the thick layer of ice encasing it, we may never know. Europa could be full of alien creatures, or it could be completely barren. That burning question may be answered in the next few years. The European Space Agency and NASA each have 2 major missions to Europa. ESA's JUICE mission launched in April 2023 and will arrive in 2031, aiming to collect new data on Europa's chemistry. NASA's Europa Clipper, launching in October 2024 and arriving in 2030, is designed to determine if Europa's ocean is habitable. These exciting missions should complement each other, but neither will confirm if aliens exist, only if the moon has the right conditions to support life. If we find life on Europa, even in microbial form, it would mean life could potentially arise throughout the galaxy. I hope you enjoyed this video. If you did, tap the like button and subscribe. There's plenty more to come. Thank you for watching, and I'll see you next time.